What's up everybody, welcome back to another video. Today we'll be learning about graphing quadratic equations in vertex form, which means in the form seen in the image below, y equals a times x minus h squared plus k. That is vertex form. So in today's video, I will be going over the steps necessary to find the proper information from your quadratic equation, which you will use to actually graph that quadratic equation. After explaining the steps to you, I will walk you through one example and then I'll give you the opportunity to try the last example on your own. So let's begin today's lesson by going over those steps. So as you can see, this is the format for our quadratic equation in vertex form. Y equals a times x minus h squared plus k. So the first step involves the a variable. We want to look at the a variable. So first you want to look at if a is positive or if a is negative. If a is positive, then the graph opens up. It increasing. It's an increasing graph. So it will look something like this. And since it's a parabola, both sides of the graph would be going the same way. And if a is positive, they'd both be increasing. Now, if a is negative, the graph would open downward. It'd be decreasing. It'd look something like this. So by figuring out the sign of the a variable, we can figure out the direction of the graph. In addition, we also want to look at the value of the a variable. Now, if the a variable is in between 0 and 1, then there comes a vertical compression, which means the graph will be wider than normal. And if a is greater than 1, then there will occur a vertical stretch, which means the graph will be narrower than usual. And it's the same thing for a negative a too. If a is in between -1 and 0, then there will also be a wider graph, but since a is negative, it will be opening downwards, it will be decreasing. And again, if a is less than -1, since a is negative and a is less than -1, the graph would be narrower and it also open down. So by looking at the sign of the a variable and the value of the a variable, we can figure out the direction and the general shape of our graph. Now that we've went through step number 1, we want to go over to step number 2, which has to do with the vertex. And remember, the vertex is the starting point of our graph. It's the point where the graph begins, and we want to find it to know what point to start our graph on. And our vertex basically has to do with the two variables h and k. Our vertex would be h comma k, with h representing our x value and k representing our y value. But there is something different to finding the x value of our vertex. Now, let's say, for example, we had a quadratic equation, and in the parentheses, we had x minus 1. Now, you think, well, since the h value is our x value would be -1. Since -1 equals h, you think -1 would be our x value, but our x value would actually be +1. For our vertex, the x value would be +1. And that's because to find the x value for our vertex, you want to find the opposite sign of the h given to you. So for example, since we had -1, the opposite sign of -1 is positive. So +1 would be our x value. So in that sense, you can basically say that -h is the x value to your vertex. And then you just find k by looking at the k value in your quadratic equation. So now that you found the direction, general shape, and vertex of your graph, the last step just involves finding some more points on the graph so you know in what sense to sketch your graph. And that just involves finding relevant x points or relevant points at a certain x value that are near the vertex by plugging in x values into your quadratic equation and finding the y value. And I'd say on your graph you should find about 5 points including the vertex. So after you find the direction, the general shape of the graph, the vertex, and some points, you can finally sketch your quadratic equation. You can finally sketch the graph of the quadratic equation given to you in vertex form. So now that we went over the steps, let me walk you through example number 1. And here it is, our first quadratic equation in vertex form. Parentheses x minus 1 squared minus 3. So let's start off by looking at step number 1, which has to do with the a. Now, since there's no number here, we can assume that a equals +1. And a +1 is a positive number, which means our graph will be opening upwards. It will be increasing. It looks something like this. In addition, our a value is a 1, but our a value isn't in between 0 and 1, which means there's no vertical compression, and it's also not greater than 1, which means there's no vertical stretch. our a value is just 1, which means we will have a normal shaped graph. There's no narrower or wider part to this graph. So now that we've done step number 1, let's move on to step number 2, finding the vertex. Well, remember what I told you about the vertex and the x value basically being negative h. In this example, we have negative 1 as our h value. But we want to find the opposite sign. So the opposite sign of negative 1 is just positive 1, which means the x value to our vertex would be positive 1. And our y value for our vertex would just be with k, which is negative 3. So negative 3. 1 comma negative 3 is our vertex for this example. So now let's put that point on our graph. 1 comma negative 3, about here. So now that we found our vertex, let's move on to the next step, the third step, which is just to find some points on the graph. And remember how I said before that you want to find about 5 points on the graph, including the vertex. But there's an easier way than just plugging in 4 more x values and finding the y values and points on the graph. It's important to remember that when graphing quadratic equations, no matter what form they're in, the graph will be symmetrical across the vertex, across the line of the vertex. So for example, the graph to the right side of the vertex point and to the left side would be the exact same but mirrored. And I'll explain that as we go through it. So for example, let's just do the points to the right of the vertex. We'll do x equals 2 and x equals 3. Instead of substituting it in and showing the work, we can just do this one in our head because it's simple math. So at x equals 2, we'd substitute in 2, 2 minus 1 equals 1, 1 squared equals 1, and 1 minus 3 equals negative 2. So 1 point would be at 2 comma negative 2. So let's put that point in on our graph. 2 comma negative 2. Now let's do a point at x equals 3. So 3 minus 1 equals 2, 2 squared equals 4, and 4 minus 3 equals 1. So we have another point at 3 comma 1. So let's put that point on the graph as well. 3 comma 1. Now remember what I told you about the graph being symmetrical. The right side of the vertex point, the right side of the graph of the vertex point will be exactly symmetrical to the left side, but mirror. So for example, it will have the same y value for the same x value. If you go 1 to the right and 1 up on the right side, you would go 1 up if you go 1 to the left. And that might sound a little confusing, but just remember it's symmetrical, which means we would also have a point at 0 comma negative 2 and at negative 1 comma positive 1. And if you look at this, these are symmetrical. Both sides are the same, but they're just mirrored. So that's what it means to be symmetrical. And now that we found 5 points of our graph, we can just make a basic sketch of our graph. It would look something like this. Now this graph might be a little messy, but it's the basic shape of what a graph is supposed to look like. So by doing those 3 steps, we have found the graph of our quadratic equation in vertex form. Okay, so now we'll move on to example 2, and I'll give you guys the opportunity to try it on your own. Pause the video if you'd like to do that. And here it is. Negative 2 times x plus 2 squared minus 2. Pause the video if you'd like to try this on your own. Okay, let me do this example. So for step 1, we have to look at the a value. The a value is negative 2. So now we know that since a is negative, the graph opens down. It's decreasing. In addition, we also know that negative 2. So that means a is less than negative 1. So that means there's going to be a vertical stretch. It's going to be narrower. So that's something important to know when we're talking about the general shape of our graph. So now that we looked at the direction and general shape, let's move on to step number 2, which is to find the vertex. So let's see, our h value is positive 2, but remember we want to find the opposite sign. So that means our x value for our vertex would be negative h, which is just negative 2. And over here we see minus 2 for our k, which is just negative 2. So that means our vertex for this example would be negative 2 comma negative 2. So let's put that on our graph. Negative 2 comma negative 2. Okay, now step number 3. Find some more points on the graph. Now remember what I talked about symmetry. We just need to find 2 points at two x value points, not 4. We don't have to substitute in 4 x values. We can just do 2 because we know about symmetry. So let's just do on the left side this time. We'll do x equals -3 and x equals -4. So -3 plus 2 is -1. -1 squared is +1. Let me write this one out because it might take a little bit more work. So -3 plus 2 squared minus 2. So then we see -3 plus 2 equals -1. -1 squared equals +1. So then we'd have -2 times 1 minus 2. So that would just be -2 times -1, or -2 times +1, which is just -2. So we'd have -2 minus 2, which is just -4. So that means at x equals -3, our point would be -3, -4. Okay, now let's move on to x equals -4. So once again, let's substitute in -4 for x. -4 plus 2 squared minus 2. Okay, so -4 plus 2 equals -2, and -2 squared is +4. So then we have -2 times +4 minus 2. -2 times 4 is -8. So -8 minus 2 equals -10. So that means we have another point at -4, -10. So now let's plug in these 2 points onto our graph. Let's put those points on our graph real quick. So 1 point at -3, -4, right over here. And there's also 1 point at -4, -10. On our graph, we don't have that much space, but let's just make an estimate of where it might be. It would probably be somewhere over, let's say, here. Right here at -4, -10. Move that a little bit down. Okay. So remember, once again, both sides from the vertex, the right side and the left side, are symmetrical. So from that, we know that we also have a point at -1, -4. And we also have a point at 0, -10. Because both sides of this graph are symmetrical. So now that we've got 5 points on our graph, let's just make a little sketch of it. Looks something like this. This might be a little messy, but as long as you understand the basic gist, you should be fine. Now, let's go over something real quick before we end today's lesson, and it's the shape of the graph. Notice how this graph is a little wider than this graph, and that's because of the a value. Since a is -2, there is a vertical stretch, and that's why this graph is narrower than the graph in our first example. And remember, to find the proper information to graph our quadratic equation in vertex form, you want to first look at the transformations or changes, which means looking at the a value and figuring out the direction, and which also means figuring out the general shape. And then number 2 is to find the vertex, which means looking at the h and k values in the quadratic equation. And 3 is to just find some points on the graph. And then finally, you want to just graph your quadratic equation. If you enjoyed this lesson or learned something from it, please consider subbing to our channel and also check out our playlist on Math 2. Thank you for watching.